I must say that I'm going to borrow that saying that you have. Fools with tools are still fools. So it is my pleasure to introduce to you our final speaker before lunch, Dr. J.P. Guéroux. Dr. Guéroux, Chevalier in the Order of the Legion d'Honneur and a former professor of geotechnical engineering. He is now a consulting engineer. He's a member of the United States National Academy of Engineering. He has a doctor honoris causa of the Technical University of Bucharest. He is past president of the International Geosynthetic Society and chairman emeritus and founder of Geosyntec Consultants and chairman of the editorial board of Geosynthetics International. He will be talking today about the use of geomembranes for lining canals. So it is my pleasure to introduce to you Dr. Guéroux.
Thank you very much for this kind introduction, and thank you for inviting me to speak today on behalf of the IGS, the International Geosynthetic Society, which was founded 35 years ago and has 4,000 members in 100 countries. And it is a very active society which has already organized 11 international conferences. I apologize for speaking from the floor, but considering the nature of my presentation, this will be far more efficient. So we are going to talk about the use of geomembranes for lining canals. Geomembranes are flexible sheets of watertight material, generally polymeric, but sometimes bituminous. Geomembrane panels are seamed together to form large geomembrane liners, which are used in a variety of applications, such as waste disposal, landfills, reservoirs, embankment dams, concrete dams, and today geomembranes are used in a variety of canals, hydroelectric canals, navigation canals, irrigation canals, large canals, as well as small canals. The geomembrane can be exposed or can be protected. The use of geomembranes in canals started in the 50s with asphalt sprayed on jute and mostly films of PVC and polyethylene, very thin, typically 0.2 millimeter thick. Here is a historic photo of the first canal lined with a PVC film in 1954 in the United States. But in spite of this long history of geomembranes used in canals, and in spite of the fact that geomembranes are today the dominant waterproofing materials in waste disposal landfills and in mining applications, many canals are still lined with concrete. There are two types of concrete linings: precast panels, which are often used in small canals and placed by hand, and cast in situ concrete linings, which are often used in large canals and placed by big paving machines. But they can also be used in medium-sized canals, as we see here. There is considerable experience with concrete linings, but concrete linings have drawbacks. Cast in situ concrete linings are not flexible, and they tend to crack if they are not uniformly supported by the soil because of causes that all geotechnical engineers know: differential settlement, localized soil subsidence, dissolution of gypsum in the soil, collapse of loess, or erosion of soil under the lining. And here we see a longitudinal crack in a concrete lining. This is another example of cracking of cast in situ concrete lining. And there had been, in this case, an unsuccessful attempt at sealing the cracks with adhesive tape. This canal is located in an area where the soil has a high content of gypsum. This happens in particular in desert areas, as in the Middle East in many cases. And gypsum is soluble in water, which explains the mechanism of the failure of this cast in situ concrete lining. Water leaking through initial cracks of the concrete lining dissolved some gypsum, which caused soil settlement, which increased the concrete cracking, thereby increasing leakage, which caused more gypsum dissolution, which caused more settlement, which further opened cracks and joints in the concrete lining, and so on, until the canal was put out of commission. So there are cases where the dissolution of large amounts of gypsum by water leaking from the canal causes the formation of large cavities in the ground. This is another example in the Middle East, where the concrete lining collapsed into a cavity formed by a gypsum dissolution. As seen in these examples, water leaking through cracks in the concrete lining can cause a major failure if the soil is sensitive to water. Now, the gypsum case that I presented in the preceding slides is frequent in desert areas, as in the Middle East, but is relatively rare worldwide. But there is a frequent case where the mechanism is similar. This is the case where water leaking through initial cracks of the concrete lining erodes the soil under the concrete lining. As a result of erosion of the soil, the concrete lining is no longer uniformly supported. Which cause cracking of cast in situ concrete lining and cause differential displacement of precast concrete panels, which we can see on the next slide here, a case of differential displacement affecting concrete panels. The displacement of concrete panels occurs also in the case of frost heave. In the case of freezing temperature, water vapor present in the soil migrates toward the cold lining, and as a result, ice accumulates under the concrete lining, forming ice lances which uplift the concrete panels. This is an example of frost heave affecting precast concrete panels. And in addition to frost heave, there is another deterioration mechanism due to frost. Concrete is a porous material, therefore concrete linings contain water, and in case of freezing temperature, when water is turned into ice, its volume increases, which progressively breaks the concrete after some freeze-thaw cycles. This is an example of concrete deteriorated by frost. Now, it should not be concluded from the preceding slides that all concrete linings have problems. There are many canals where concrete lining is performing well. However, the preceding slide shows that there are several mechanisms that can deteriorate concrete lining. Therefore, a number of canal linings have been repaired and need to be repaired, and there are many examples of defective concrete-lined canals that have been repaired using geomembranes. Now, it should be noted that many geomembrane linings having an excellent performance are protected with a concrete layer. So a good way to use concrete in canals is as a protective layer of the geomembrane lining. The geomembrane ensures the water tightness, and the concrete ensures the protection of the geomembrane. This leads us to discussing water tightness. The evaluation of water losses in canals, and in fact, therefore, the evaluation of water tightness of lining materials is a major subject of discussion in irrigation canals. Two methods are used to measure water losses: the inflow-outflow method and the ponding test method. The unit typically used to express water losses in canals is millimeter per day, which is a unit of water level drop. The inflow-outflow method consists in comparing the flow rate at a certain point along the canal with the